Hi, I'm Ed Zinda, and this is What the Funk. Hello, and welcome to another tutorial on writing Ethereum smart contracts in Solidity. In my previous video, I kind of showed you a real quick and dirty introduction to creating smart contracts in Solidity for the Ethereum blockchain. In this video, I'm going to actually go a little bit further in depth and kind of explain things a little more. And I'm going to do that in a series of other videos as well. So let's get started. Like before, I went ahead and navigated over to the Ethereum official online, I guess, IDE, if you want to call it that, over at ethereum.github.io /browser-solidity. And I made sure to select the JavaScript virtual machine. And then I went ahead and created a file called whatthefunk.sol. And then just like every Solidity contract file, you need to specify the compiler version with the keywords pragma, solidity, and then the actual version number. And then we're just going to create a contract called What the Funk. So we have a contract that does nothing. It's created and published to the blockchain. And remember that every Ethereum contract, when it's published, is actually part of a transaction on the blockchain. So just like payments are a transaction, contracts published to the blockchain are also a transaction. So they are a transaction, and they also receive an Ethereum address, so you can actually send money to it, but we won't really talk about that in this video. So the first thing we'll do in this contract is create some state variables. And state variables are strongly typed, not like languages like PHP or JavaScript. You actually have to specify the type of the variable before you declare it. So we're going to declare two variables. The first one is a string. We'll call it word. And then we'll set word to bird. So bird is the word. And then we're going to create an integer, an unsigned integer. So you have integers, unsigned integers. An integer can be either positive or negative. Unsigned integers are always positive because they can't have a sign. So we'll do an unsigned integer, we'll call it number, and that's going to be 42. So go ahead and create that, and we've got the contract created, and as you can see, it still does nothing. You can't even see the variables we created. In order to make those variables accessible to the public, we use the keyword public. So we create that again, and by making those variables public, we've actually created getters for those variables. Actually, the Ethereum virtual machine will create getters on its own. So you can actually run them like they were retrieval functions on the contract. So you can click word and it'll display bird, and then number, it'll display 42 because that's all that is in there right now. But what if you don't want to make your variables public? What if you just want to keep them internal to your contract and not available to the public, and maybe only give access to one of those variables? So you would create what is called a getter function. So you make those variables private again, and then we create a new function We'll just call this get word. And to let the Ethereum virtual machine know that this is a getter function and it's not going to alter the state of your contract at all, you use the keyword constant. And then you also, for this function, you have to specify the type of whatever you're going to be returning. So we tell it that it's going to return a string, not a strong. Then we simply return word. So we create this again. Now we have this new getter function with our own special name. We can name it whatever we want, but in this case we named it get word, and it'll retrieve bird. One other thing I'd like to explain is that the Ethereum contracts and state don't actually work like you would think, like in most programming languages, because it works on the blockchain, which is just a ledger of transactions, one after the other sequentially. Really all state is, as far as contracts are concerned, is basically the Ethereum virtual machine is just returning the last known value of that variable as it exists on the blockchain ledger. So the last block, the most recent block, will have that value written down, and that's what what Ethereum is retrieving when you're running those getters. And that's why we use this constant keyword. So what if you want to change this variable from the outside? Because it's private, you can't really access it. So the way we do that is with a setter function, the opposite of a getter function. So we'll just call this set word, and it's not a constant. It will actually make a change to the blockchain. So when we actually set the word, it will it'll write a transaction to the current block, and that will be saved on the ledger permanently. So setters also take a variable with a type, but they don't return anything. So that's what that looks like. And so we take in a string, we call it W, and basically we're just going to set word to the value of W. And we go ahead and create that. And this, we see this new set word function down here. And because it's a string, we have to enclose it in quotes. So we'll set the word to dog. And everyone knows bird's the word. Dog is not the word. But in this case, this is just for example. So we've set the word to dog. And if we go ahead and hit the get word getter again, it returns dog, sure enough. So we've got getters, setters. There's one other type of function I wanted to go over, and that is the constructor function. So when you create an Ethereum contract, that deployment itself is a transaction. If you create a constructor on this contract, that function actually gets called as part of the transaction, and that is the only time it ever gets called. So basically you would use a constructor for any sort of setup work you want completed on the contract, like setting variables to default values, running all sorts of other stuff, but you only want that run once, and you don't care if it ever gets run again. So instead of initializing these variables up here, we'll go ahead and create a constructor. And constructors take the same name as the contract that they are a member of. So we'll call this what the funk. And then we'll go ahead and set word to bird and number to 42. And if we create that, we see that word is bird again. And if we go ahead and just set number to public for the time being, we can see that actually gets initialized to 42 as well. Now, say you want to restrict access to certain functions from the outside world. Let's say that we only want the owner or the creator of this contract to be able to make any sort of modifications to its internal state. So in this case, we're going to use what are called modifiers. So first, let's create a variable of type address. Now, address is a very special type in the Ethereum virtual machine, and all that is a it's a memory location that just stores Ethereum addresses. So like an address for your wallet or an address for your actual contract. So we'll just call this address owner, and this is going to stand for the actual creator of the contract. And in the constructor, we're going to set owner to message.sender. Now, because creating a contract or deploying a contract is actually a transaction on the blockchain, it is actually being sent from an Ethereum address. And every transaction on the blockchain has a corresponding message. A message is just like a container object with a whole bunch of metadata. And sender is actually just the address of whoever initiated that transaction. So by placing this in the constructor, message.sender actually corresponds to the address creating this contract. So now we've privately saved the address of the creator. So the next step is to create what is called a modifier. And a modifier is just kind of a logic test, if you want to think of it that way. So we'll call this modifier only owner, which means only the owner of this contract can actually make modifications. And basically we run a test that if the message.sender is not equal to the owner, we're going to throw an exception or an error. And remember, so message.sender actually corresponds to whoever is sending the current transaction. So in this case, it's not necessarily the owner of the contract that could be sending the message. It could be anybody executing one of these functions over here. So if they're not the owner of the contract, we want to throw an error and then abort the transaction. But if they are, we'll go ahead and execute. And this underscore right here is just a placeholder for the function you want to modify. So we're going to modify this setWord function over here. And so because we modified this setWord function to only owner, the body of this function will actually be run right here. So just think of this as a placeholder for whatever function you're modifying. So we'll go ahead and create this. Now, I created, when you work with this Remix testing IDE, it gives you actually a list of different addresses to play with. So the first address is the address that actually created the contract. So we can go ahead and set word with no problem, because we're still using the address that we created this contract with. So if we set word, everything went okay, and if we use get word, we get dog. But let's use another address in the list, and we'll try and set back to bird and see what happens. Now you'll see that an exception was thrown, and we weren't able to actually set the word, so it's still dog. So that's how you can actually prevent people from using functions they aren't allowed to use. Now, one I think more readable way of running this test is using the require keyword. So all require is basically just an if statement, and if the condition doesn't resolve to true, it'll throw an error for you. And I think this is actually more readable and a lot easier to type, so it saves space. So we can do the same thing, require message.sender to equal owner. So it's actually the opposite of the if statement that we wrote before. So instead of throwing an error if the sender is not the owner, we require the sender to be the owner, and then we continue on. So we can do the same thing, change the address, try to set bird to dog. Nope. And we still get the error. The one final thing I wanted to cover in this video is what are called events. Now, an event in Solidity is just a way to call the Ethereum virtual machine's logging functionality to write a log entry to the current block as part of your transaction. And these logs are useful for decentralized applications because say you have your Ethereum contract, and then on the publicly accessible internet you have a user interface for your dApp. This interface is probably going to be written in JavaScript using the Ethereum JavaScript SDK, and the Ethereum JavaScript SDK is able to listen to the Ethereum blockchain for events. So you can tie these events to JavaScript callback functions in order to run any kind of logic on the UI or the other piece of your application that you want. So in order to write one of these log entries, you need to create an event. So we're going to create an event called changed. And an event is kind of like a function in that it takes parameters. So this changed event is going to take an address, and in this case we're going to log anytime somebody makes a change to the word variable. So we'll call the changed event, call message.sender, or send it message.sender as the address, and that way we know that someone from that particular address made a change to the contract. So let's go ahead and create that. Go ahead and change to dog. And then you can see right here an event was actually logged. So now we can listen from the user interface part of our app, or the JavaScript portion of our application, and then do something based on that change. So in this lesson, we covered basic state variables, functions, getters, setters, constructor functions, modifiers to functions, and events. If you enjoyed this video, please click like. And if you enjoy the overall content of this channel, please go ahead and subscribe, tell your friends about it. And I'm looking forward to putting out some more content on Ethereum and Solidity, as well as several other languages. So I look forward to seeing you in the next video.